Hey, what's going on guys, it's Hanson. So we're back with a brand new video, and I just want to talk about data types in this video. In the last video we talked about variables. I showed you guys how to declare variables, and we assigned those variables a specific value. Now each value has a certain data type. So for example, if we look over here, age, this variable over here has the value of 22. And you're probably wondering, well, what is the data type of age? Well, isn't it just a number? And if you guessed the number, then you're correct. It is a number. Likewise, over here, we have the variable name. And the variable name itself has the value of Anson. And you're probably wondering, well, what is the data type of name? And that is a string. We're not going to talk so much about strings, but I just wanted to briefly talk about that right now. But in the later episodes, we will go through it. Okay, but you can see right over here on line 8, we have a constant variable, and the data type of this constant variable is a number, but it's not just any ordinary number. It's actually a floating point, like a number with decimal points, so like 123.456, etc., 5.2 in this case. Now there are many different types of data types in just programming languages in general, but we're going to talk about the main 4 in this video. There's something called scalar types, and scalar types represent a single value. So for example, we have age. This represents one single value. Multiplier. This represents one single value. Okay. In Rust, there are 4 primary scalar types. There are integers, floating point numbers, booleans, and characters. Okay. So first, let's talk about integers. Integers aren't really anything crazy in programming. They're just numbers. Okay, but more specifically, they're numbers that don't have any floating points or any decimal points. So for example, right over here, 22, this number itself is an integer. Okay, 5.2, however, is not an integer. Okay, there's a huge difference, and if you've taken a basic math class, they would have obviously went over the differences. Okay, now in programming, there are actually several different types of integers, and you can actually go on the website, and we're just basing everything off of this, but you can see that there are different types of integers. There's 8-bit, 16-bit, 32-bit, 64-bit, and 128-bit. And now these are the sizes, but the main 2 are signed and unsigned. So let's say, for example, if we're talking about signed integers. So when you hear the term signed integer, what that means is the number itself, okay, the data type, can hold negative values. Think of it like this. In the real world, when you denote a negative number, you use a sign. You use the minus sign in front of it. If it doesn't have the minus sign, it's implied that it's a positive number. So when we're talking about signed integers, that just means that the number can hold negative values. The data type can hold up to negative values. That's all it is. Okay, so if we have a signed 8-bit integer, that means that 8-bit integer can have up to 127, and the smallest number can be negative 128. Now, we're talking about signed right now. We'll get to unsigned in just a bit. So there are also different sizes for our integers. There are 8 bits, 16 bits, 32-bit, 64-bit, and 128-bit. And the size itself basically allows us to hold up to a certain number. So if we're talking about an 8-bit signed integer, there's actually a formula that you can calculate to tell what is the range of numbers that we can have for a signed 8-bit integer. So this is exactly from the documentation, but it's also a common thing that is studied in computer science. Okay, but right over here, we have this formula over here. So n in this case is the number of bits. So if I want to calculate the size, the range of an 8-bit signed integer, I would just plug in 8 inside this formula. So we would just simply do 2 raised to the 8 minus 1, so that's 2 to the 7th. And if we plug this into a calculator, that would just simply be 2 to the 7th, which is 128, and then multiply by 1. So that's negative 128. So this is the smallest number a signed 8-bit integer can be. Now, if we want to find the largest number, well, we take 2 and raise it to n minus 1 and then subtract 1. So that's just 2 raised to the 8 minus 1, so that's 7th power. So 128 subtract 1, so 127. So this means that a signed 8-bit integer can have values between negative 128 up to 127. And we can verify this too. Let's go inside our code and let's create a new file called datatypes.rs, and we're going to have our main function. I'm going to keep repeating this. Every single program needs to have the main function. Okay, so make sure you have this main function. And we're going to go ahead and declare a variable. So let's just do let So that's the keyword. And I'm going to call this num1. And we want to give this variable an actual type. Okay, so we're going to use the colon. And then we're going to go ahead and denote it as a signed 8-bit integer. So to do that, we need to use I, which stands for signed. And then we're going to specify the size, which is 8. Okay, and we're going to assign the value of negative 127. Okay, well, wait, let me give it 128. Okay, there we go. So now, if I want to print this out to the console, I can. So remember, to print to the console, you have to use the println exclamation mark function. And inside, you have to wrap this inside quotation marks, the curly braces. You have to wrap it inside quotation marks. And then you have to specify comma, and then num1, the variable that we want to print out to the console. Okay, so this value over here, the value of num1 is going to replace the curly braces. It's going to basically substitute the curly braces over there. Okay, so the curly braces aren't actually going to be printed. It's just a placeholder. Think of it like that. So let's do rust c source. Let's first compile it to rs. So we shouldn't get any issues. Perfect. And to run it, we're going to go ahead and just type data types.exe. And there we go, negative 128. Now, if I try to give it the value of negative 129, and if I try to compile it now, it's going to give us an error. Notice how it's saying literal out of range for signed integer 8 bits. Okay, it's overflow. We have an overflow error. Now, the same thing is going to happen if I give it the value of 128. Okay, we're going to have an overflow error. But if I give it 127, which is the max, that's going to be just fine. So let's run it again, 127. Okay, it's that simple. So just to recap, all we've done was we declared a variable and we gave it the type of a signed 8-bit integer. Okay, and for 16 bits, we can do the same thing for 16 bits. So let's do let num2 signed 16 bits. Okay, and for 16 bits, the range is from negative 32,768 all the way up to 32,767. So literally all you have to do is just plug in the bits into this formula over here, and you can calculate the size. Okay, and the same thing for 32 bits and 64-bit and 128-bit. So let's say, for example, let's assign this to 300, and that should be just fine. Okay, so now that you guys get the gist of signed integers, let's just talk about unsigned integers really quickly. So unsigned integers basically are the opposite of signed integers. Okay, so unsigned basically just means that the value itself is not going to ever be negative. That's it. Now, if we want to calculate the range of an unsigned integer, it's very easy. Unsigned integers go from 0, which is the smallest value, all the way up to 2 to the nth power minus 1, where n is the number of bits. So if we were to throw this into our calculator, we would basically just type 2, raise it to, let's say, for example, we want to get the size of 16 bits. 16, so 2 raised to the 16th power, subtract 1. So an unsigned 16 bit integer can hold values between 0 all the way up to 65,535, and we can verify that. So let's do let num3, and to do unsigned, you do u, and we're going to go ahead and do, let's see, 16, and we're going to give this the value of, let's give the value of 65535. Let's give it 65536, and if we try to compile it, notice how it's going to give us an error. See how it says it's overflowing, but if we give it the value of the max, it's going to go ahead and say, let's see, it says unused variable. So these are warnings, so don't worry, they're warnings. Okay, but it's fine. We can still run our program. They're not compilation errors, they're just warnings. So let's print out two variables. So let's print out two variables right now. So we're going to print out num2 and then num3. And if you want to print out more than one variable, you can just specify more than one pair of curly braces, and make sure you pass in the variables in the correct order. So in this case, num2 is going to replace this placeholder over here, and num3 is going to replace this placeholder over here. So let's compile. Okay. And there you have it. Very simple. Very simple. The reason why we were getting that warning was because it was saying it was unused, but when we actually use it by printing it to the console, it's actually being used, so the warning went away. Now there's actually one more length for our signed and unsigned, and that's called Isize. So let's declare a variable called num4 and give it the value of Isize. And this depends on the type of architecture that you're running on, and it says it right over here in the documentation. If you're on a 64-bit architecture, then the Isize is going to be 64 bits. If you're on a 32-bit architecture, then the size of Isize or usize is going to be 32 bits. So that's important to know. So for example, my computer is 64 bits, so we can hold values all the way up to 64 bits. So let's just give it a 50. Nothing significant, but just wanted to point that out. And likewise, we also have floating point types as well. So in the last video, I showed you how to declare a floating type variable, which is what we have over here, const multiplier. And floating types also have sizes too. So we can go ahead and say, let's just declare a variable called tax rate, and let's give it a floating point size of 32. And we'll just say 50.70. That's a very high tax rate. And we can do the same thing for, let's, I don't know, grade percentage F64 or 64 equals 90.2. Now, obviously, you're probably wondering, well, when do you use which size? And that depends on the data that you're dealing with. If you have, like, for example, a very large number that you have to take care of, you might not want to use a signed 8-bit integer. Now, there are actually only floating point sizes of 32 bits and 64 bits. So there aren't, 8 bits or 16 bits, just 32 and 64, which is less confusing, of course, for floating points. And that's pretty much it for data types when it comes to numeric values. And there's also two other data types that I want to talk about before I end this video. There are Boolean data types, and Boolean data types just have two possible values, true and false. That's it. Okay, and they're used for conditions. So when we actually talk about conditions to control the flow of our application, we're going to be using Booleans as well. But for now, I'll show you a quick example. So let's just say, let's declare a variable called isMale. So I am a male. So of course we're going to set the value of this to true. And you can see that I'm inferring the type as bool. I'm giving the type of isMale bool. That basically means that yes, I am a male. The value of isMale is true. Now we can do the same thing. Let isFemale. I am not a female. So we're going to give it the value of false. There are only two possible values for Boolean data types. Okay, and finally we have the character type. Okay, and basically characters are just individual letters. So we can do let C, and then we can just say car, and then give the value of C. Okay, very simple. And again, if I want to print all these out, I'll just do so by just simply doing, let's print out isMale, and then isFemale, and then let's print out the character. Okay, very simple stuff. Oh, whoops, meant to do exclamation mark. Apologies. Alright, so let's recompile our code. And we're getting warnings, but don't worry, the program's still going to work. And you can see we have true, false for isMale and then isFemale respectively. And then character C right over here. Very simple stuff. Okay, nothing too crazy. And that's it for these scalar types. In the next video, we're going to talk about compound types. And that's pretty much it for this video. So in the next video, we're going to go ahead and actually talk about arithmetic in programming in Rust. And I'll see you guys in the next video. Peace.